In this short video, we will learn about the structure and bonding of covalent compounds. By the end of this video, you should know what melting and boiling points covalent compounds have, be able to describe the bonding in covalent compounds, and understand why covalent compounds do not conduct electricity. Have a look at these examples of common covalent compounds: butane, sugar, water, and oil. Are they solids, liquids, or gases at room temperature? How does this differ from ionic compounds? To answer this question, we're going to look at the bonding in covalent compounds. When two nonmetals form a bond, they both want to gain electrons. Unlike ionic compounds, where electrons are passed from one atom to another, in covalent compounds, electrons are shared between atoms. Let's look at an example: fluorine. Fluorine is in group 7. It wants to gain one electron to form F-. When we bring two fluorine atoms together, they both want to gain one electron. They do this by sharing one electron each. This way, both fluorine atoms appear to have 8 electrons. This forms an F2 molecule. Let's look at another example. Carbon is in group 4. It wants to gain 4 electrons. Oxygen is in group 6. It wants to gain 2 electrons. If we share 2 of oxygen's electrons and 2 of carbon's electrons, the oxygen atom will be happy, but the carbon atom still wants 2 more electrons. Let's add another oxygen atom to share 2 more electrons with carbon. Now the carbon atom is happy too. We have made a molecule of carbon dioxide. Once an atom has gained the number of electrons it needs by sharing electrons, it will stop forming new bonds to other atoms. This means that many covalent compounds exist as small, discrete molecules. These are molecular covalent compounds. Some covalent compounds exist as giant networks instead, such as diamond or sand. These are network covalent compounds. Covalent bonds between atoms are strong. However, there are no bonds between molecules. Therefore, the molecules are easy to separate. This means that molecular covalent compounds have low melting and boiling points, and thus they can be solid, liquid, or gas at room temperature. Molecular covalent compounds have no charged particles. This means that they do not conduct electricity, even when molten or in solution. In a covalent network, all the atoms are connected to each other with strong covalent bonds. Covalent networks have high melting points because the atoms cannot be separated easily. Diamond is an example of a covalent network. Covalent networks in general do not conduct electricity because there are no charged particles, but there is one notable exception, and that's graphite.